Today here we have Mandi with us, and Mandi is the technical community manager at Chef.
Yep.
And we're going to talk a little bit about how InSpec can help with assurance, how it can eliminate some of the boring tasks of security. So please give a big round of applause, and over to Mandi.
All right, so we're keeping with the theme of female speakers with purple hair dressed in blue. My flowers today are lilies of the valley, so just for your notes there. All right. Yes, no? No? Play? Doesn't want to auto-advance? Any ideas? Spacebar? Hello, computer. No. Let's see. No. Arrows? No. It's going to be one of those days. We'll get a little started, but that's fine. So yeah, my name is Mandi Walls. I work at Chef. We are actually based here in Seattle. We're down in Pioneer Square. And we do, have you heard of Chef? Anybody? Most people, awesome, thank you. Sometimes I get in a room and they're like, who are you again? So Chef started out doing configuration management, systems automation, that kind of stuff for mainly operations people, right? But a few years ago, we acquired a company based in Berlin that had been doing some security testing framework stuff for Deutsche Telekom and a couple of other larger German companies. And one of the products that they were working on was it's called InSpec. So has anybody heard of InSpec? Has anybody heard of ServerSpec, which is sort of its earlier cousin? So these are tools that were, if you read some of the top-line stuff about them, the focus is on testing your security code in an infrastructure as code sort of way. And I'm going to ignore that part of it for right now. So if you don't write infrastructure code with Chef infrastructure or Puppet or Ansible or that kind of thing, don't worry about that stuff. So we'll eventually get my contact information up there. That's fine. If you want to get in touch with me, I'm LNXCHK anywhere but Snapchat, because over 40, you probably don't want to be on Snapchat. That seems like a bad idea. So what we do at Chef, like I said, we started out, awesome, thank you. Okay, don't touch it, okay. Oh, you can see all the uncool stuff I have on my dock down there. So a couple of years ago at our conference, we had the CTO of Alaska Airlines, who are also based here, give a keynote talk about what Alaska does to do technology stuff, right? Alaska is they're an airline, right? The main thing they do is fly planes places. But to differentiate what they do in that space, a lot of what they were adding as far as customer behaviors, as far as value add for their passengers, is technology-based. And a lot of those things are not necessarily the most intuitive sort of stuff that you would think about with an airline. But basically, he told us that they're going to be a software company with airplanes. And you think about the massive capital costs of buying or leasing airplanes, plus the cost of berths at airports and all those things. But the real place where they were differentiating and being different, being special, is with their technology sector, their software, and the things that they were sort of making available that way. So as we're thinking about this, looking at not only who we work with as far as things like Alaska Airlines, banks, financial institutions, educational institutions, the government, all these folks that are increasingly moving towards software-based solutions for everything, we're finding that a lot of what they're also doing is being overwhelmed by the security requirements that they are now faced with, things that they maybe weren't expecting 5, 10 years ago. A couple of articles I kind of pulled out over the past couple of years. This one is Honda had to shut down a plant line, so manufacturing of cars, because they had an infection in the windows management systems that were running some of their automation robots, right? You don't really think about that as being a software problem, but you have to stop making cars that you drive because you have a problem on Windows. And it was kind of insidious. They had patched the problem, but hadn't patched their golden image, and all the running instances were fine at patch time, but T plus N, where they instantiated new ones, bad stuff was still there, right? So Chef's like, hey, this is an infrastructure automation problem, right? This is software that we know how to work with, how to talk about. This one, too, this is a HIPAA fine because they left the default password in a piece of software. We're like, come on, we know how to fix this stuff. We know how to automate this stuff. So these help us, talk about the boring parts of security with operators, with developers. This is not razor and blade hacking your Gibson. This is like the stuff that gets lost because you have N number of microservices, you have J number of runtimes, you have all this other stuff that you have to worry about. Plus, you're getting requirements from different places. I mentioned we work with financial institutions. They've got a compliance team that these folks don't necessarily need to be really technology savvy. They're not on the keyboards doing fixes a lot of times. They have a document that they're working with. They have some kind of requirements that they're basing their stuff off of. Sometimes it's a PDF file. Sometimes it's an Excel spreadsheet. Sometimes they've got a requirement to follow CIS. Okay, pop quiz. How many pages is the PDF version of the CIS standard for RHEL 8? Yeah, 500 to 700 pages for Linux platform CIS standard. Nighttime reading, anybody? If you've got insomnia, it's right in there for you. You've got your security folks that are down the hall in their cubby, and they've got stuff that's coming in from your upstream vendors. They're worried about kernel module problems. They're worried about runtime problems. They're getting tools from a completely different location. Then we have our dev and ops people who have their own set of tools, their own set of requirements. And what we wanted was something when we're talking to these folks about all the things they're doing, and we want to say, you're going to be faster with automation, you're going to be really good at this, you're going to speed up your pipelines and all these things. All the security requirements that these folks care about can be integrated into that sort of thing. So we want one place where everybody can contribute the things that they need and get the feedback back from that tool. In this case, the tool we work with is called InSpec. So what we're working towards is giving every stakeholder in the team, human-readable language for tests related to security and compliance. And what that means is I don't want it to be in some obscure language, right? I want it to be as close to English as possible without being COBOL, right? So something that people can understand what I intend when I encode all these requirements into a piece of code. I don't want to scare people away. I want to be able to create, share, and reuse these profiles that I am going to sit down and actually create for my team. I could have hundreds or thousands of requirements, sort of line-by-line pieces for different components on the system, and I want that stuff to be able to be in a place where everybody can consume it and everybody can work with it. At some point, I'm probably going to want to build my own rules for it. Like, the InSpec team is a combination of folks who work for us, as well as a very vibrant open source community, and they're sort of constantly reworking and adding things to the tool. But there's always stuff out there that we don't see, we don't necessarily know. There's a lot of software out there in the enterprise that could use some security boundaries, could use some things to be looked at. We've maybe never seen it before. So underneath the covers, InSpec is Ruby. You can add your own components to it if you so desire. It's also a command line tool, so we plug it into our build process as many times as you want to. It's pretty fast. You can divide up the profiles into little pieces, run it wherever it needs to be. So you can test early and test often for the stuff that feels mundane, feels boring. I don't want ports open. I don't want these services running. I want to make sure that what I'm shipping doesn't violate all these sort of baseline rules. So you don't want complex compliance or security components, requirements to slow you down, right? Just like the last speaker said, you want to be as fast as possible. The end goal of the software creation is to get it out in front of customers who are going to hopefully pay you for it, right? different information and expertise lives in a lot of different teams. You have your security folks, you have your compliance folks, you have your operational people who are maybe the subject matter experts on the actual platforms that you're using, and don't necessarily have all of that knowledge in every team, and you shouldn't need to, right? You should be able to have everyone come together and work on the same tool. So InSpec itself is code. You can check it into repos, right? You can publish it as artifacts. We'll look at that during the little demo. You can include InSpec steps before code check-in. You can include InSpec text steps in integration and pre-production. Make sure nothing that's been changed with a new feature add that opens a port that shouldn't be opened, that adds a library that has a known vulnerability, any of those kinds of things. Once you get into production, you can continue to run InSpec in such a way that it helps you maintain your knowledge across the entire installed fleet. So when a new vulnerability is announced, you can push a scan out and have it come back and tell you 45% of your fleet is vulnerable to this, and then work on a fix. So for an example, maybe you get something like, and I used to be a sysadmin. I worked for a long time at AOL, and we had an infrastructure security team that would randomly send us emails about, here's the thing we need you to patch this week, and you're like looking down your list of thousands of nodes, and you're like, when do you want this by? And they're like, Friday at lunchtime. And you're like, no, that's not going to happen. So you get some kind of like random directive about how to fix something, or maybe you're the one publishing the directives, right? And you're like, I need these guys to fix all this by Friday. So something like, maybe you want to ensure that no legacy network services are installed on all your versions of Linux, including some number of old stuff that, even though we're maybe years past the useful lifetime of these protocols, they still get installed. They're still around. There's still packages for them, just in case somebody might need it someday. So how do we go about looking at these things? Where are we going for checking and fixing? We identify the package names on your systems, right? Human knowledge steps in and says, well, okay, on CentOS and RHEL, it's this thing. On Debian and Ubuntu, it's this thing. Oh, we started using Amazon Linux over here. Could you check what exactly that package name is for us? You could remove all the packages. That's certainly a solution. You want to make sure you're rebooting all your currently used images, rebuilding them, right? You don't want to fix all the running instances and then have a vulnerable instance pop up later. We want to ensure it doesn't get reinstalled by accident sometime later as an unintended dependency of something new, or as a new platform that we're deploying, as a new piece of a new feature. We want to make sure that even during runtime that we're still covered. So for something like inetd, zinetd, the actual component, this is the InSpec code that actually would check for that. I have a couple of things there that help me understand what's going on, but then also just do the work, right? So it's close to English. You know, if you're fluent in English, you're going to read and understand English. I have a control, which is basically saying this is an InSpec test. That's my thing. I give it a name, which could be completely arbitrary. I can give it an impact. This must be fixed 1.0. Anywhere from 0.1, you need to know about this, to 1.0. I give it a title, which helps my not technical frontline folks understand what I'm actually fixing. So this is the do not run deprecated protocols as the title. So I can take this to my C-level folks. I can take this to folks who don't necessarily need to know all the nitty-gritty. I can describe where I found it or where it was required. I could put a JIRA ticket number in there. I could put a GitHub issue number in there. Any kind of notation that tells me why I'm actually pushing this thing in here. And then I actually do the work. Here I'm describing two packages. And the testing language is built on spec. If you come from Ruby, hopefully it looks familiar. And I have the package name, and I say it should not be installed, right? So very clear about what my intention is and why I'm intending to do that. So some core components, we have resources, resource characteristics, and then profiles that sort of gather all those up. And the final part, you actually execute this on the command line. So resources are built-in ways of looking at the system. So the atomic components of your system. There's a lot of built-in stuff, forget the numbers, like 70, I think, right now for Linux, for things that you're looking at like users, files, directories, services, packages, those kinds of things. You can dig around in dev a little bit, that sort of stuff as well. It's basically a tool that's going to go into your system, open all the closets, peek under the bed to see where everything is and where it should be. There's also some Windows specifics, like registry key and things like that, that only apply to Windows platforms. Every resource has some number of characteristics. When you think about file has a size at M time, C time, all that kind of stuff. But there's also more sophisticated characteristics for opening up things like httpd.conf for checking in there. So there's some of those built in as well. System resources, directory, file user group, those sorts of things. Specific services that we see a lot or we're dependent on or the InSpec team itself has used in the past, things like Apache or Nginx, RabbitMQ, Postgres, IIS, all built in. Programming languages components, right? Think about how many vulnerabilities you might have in a gem or in NPM characteristics or PowerShell components, those sorts of things you can check there as well. Network services, basic stuff like port and protocol, but also more sophisticated checks for things like HTTP components and SSH. All of them are fully documented in the docs there. When we dig down into what it's actually looking at then, things like the characteristics underlying all these components. For basic stuff, files, directory groups, we can check if they're even there, right? Should exist. Super easy language, it should exist. Packages that should or should not be installed can negate all of these as well. Services that should or should not be enabled or running, right? Then I can get down into serious config files, right? So something like rotating the audit D-logs, which is part of the CIS requirements, right? So looking at that, checking inside the config file for a specific setting for some number of these config files that are included. If my config file happens to not be there, I can write my own. Also, I can run any arbitrary checks as a command, as long as they return codes like 0 if it was successful, right? So I can add that in. So you think about some of the stuff that you might get from your upstream vendors. Run this command to see if you're vulnerable. Well, there's no reason to rewrite that. I can actually run that command and have InSpec check that for me so that I know, hey, this thing from my OS vendor is okay. And I can produce that as part of my regular reports. So I can run it. It's a command line tool. I can install it on my workstation, either as a Ruby gem or a part of some of the Chef packaging. It can be run locally, so I can test the machine that I'm actually running on. I can run it remotely, so it will log in to a remote system, bring all of the tools along that it needs with it, so you don't fuss around with the actual target system, and run the tests from there. And that will do that over WinRM or SSH. So how often do we check this kind of security? As someone who worked in operations, we maybe get an audit request maybe twice a year, and then you'd have 6 months to fix whatever came up. We work with a number of customers that sort of still operate on that path, and then you're considered done, and you sort of don't check it again until the audit happens. Meanwhile, the system's doing things, right? Maybe it's getting updates, maybe there's new software, and you don't have that sort of regular accountability. So we end up working with folks who have these yearly or twice yearly audits and fire drills that they don't really know the state of their system on a regular basis. So we want to move things more as part of the software development lifecycle. Previous speaker talked about moving things to the left, making things easy, and making it part of regular builds. So we can add run InSpec on things like your build nodes, running Jenkins or something like that. Ensure they meet your requirements before the builds are executed. There's no vulnerable library versions there. You're checking for things like that before the build even executes. You can run smaller targeted profiles at code check-in. You haven't enabled something bad in your Java runtime that makes it vulnerable. We run it in our integration environments to make sure that we're still validating firewalls, port controls, those sorts of things. No new settings, nothing new has been introduced in my latest check-in that causes a problem or introduces a vulnerability. Then we run it in production as often as we want to, right? It'll run as an agent. If you'd like to run it that way, you can run it as a on-request scan across your hosts that way as well. And then you can know, sort of in minutes, if you've got a new vulnerability, you update your tests, push them out, run them, and then you can know within minutes how vulnerable you might be across your fleet. So if I execute it, I can just run it right there locally, InSpec exec, and then the tests themselves are in little RB files, or Ruby files. And then it reports back to me what it's looking at and whether or not things were good or bad, right? Green text for folks who can see color. Good stuff. Test any target. There's what it looks like locally. There's my SSH remote. It borrows the SSH subcommands right from SSH itself. Then we can also talk over WinRM, or we can look into Docker containers. So where the power really comes into InSpec, and some of the stuff that's really interesting about it, are these profiles. And a profile is a way of gathering up a bunch of requirements and saying, this is my profile for Linux. This is my profile for Tomcat runtimes. This is my profile for whatever else I might have, Postgres databases or Oracle databases or whatever. And you can group them by team. This is my business development unit N requirements, or by application, or by platform, or however it makes sense for you to sort of like combine all these things together and make these artifacts that help you secure all your stuff. Every profile can have multiple test files. You can add new libraries. They're very flexible that way for what you can actually put into them. So can be specific for software only you use. If you've got COTS, you've got homegrown stuff that has an interesting customized runtime or whatever else. There's a lot of examples at dev-sec.io. This is the sort of the homepage for the InSpec open source community. So there's a lot of folks in there. Some of them are in Germany, some of them are here in the US that are working on these profiles. One of the sort of main ones is called Linux Baseline. So this is a mishmash of some stuff that comes out of CIS, some stuff that comes out of a NIST set of requirements, but there's sort of the highlights of some common security controls for the actual infrastructure layer that you'd be working on. This particular example is looking at the file etc shadow. Most of the time, we figure that when we install the machine, etc shadow is going to be okay, and it's going to be set this way, but we want to continuously ensure that it's always the way we expect it to be. Whether it's, hopefully it exists, right, and it's a file, it's owned by our root user, it has a specific group owner, and those sorts of things all sort of get encapsulated. So any of these particular little pieces of the infrastructure, I can test all these characteristics. So I have a little bit of a demo. We'll cross our fingers that the demo gods are with us. And I'm going to work with this Linux baseline profile and sort of give you an idea of how it sort of hangs together. So let's take a look at the profile itself first. So this is all stored on GitHub here. And there's, a nice README on how to work with it. If you happen to be running configuration management software and you'd like to fix all the things that are included, that's there as well. So where the actual requirements are recorded are in these controls files. And each control can work with or inspect a number of different resources on the system. So let's take a look at, say, package spec.rb. And they have names and numbers to identify them so that when something goes wrong, you can tell what the problem is, where it came from, and what to do to sort of look at remediating it. So for this particular one, package 01, this is the one that I stole from my earlier example. This is looking at inetd, inetd. And we have our title, we have a description, right? So we pulled this out of NSA requirements to make sure these things aren't installed. And you can have any number of these in your profile. And there's a whole bunch of them here, right? The other bigger part of this profile ends up being OS spec, 230 lines. And this goes in and really digs down into some of the deeper components of the system. So we're looking at things that we assume are going to be correct, but we want to ensure over time that they're not drifting, that someone hasn't gotten in, that things aren't unnecessarily vulnerable over time. So things that shouldn't be in the path, log and defs, just sort of a collection of stuff there, okay? So I can get this on my host in a number of different ways. I'm just going to SSH into a box that I booted up in AWS. Like, maybe that's a no-no, right? Could be. You probably got custom AMIs or custom images, and if you're using cloud providers, you're hopefully providing that to your teams. Maybe I'm looking at a new requirement. I have a new application that's saying, hey, you want to run this thing, we've only certified it on X. Maybe I don't have an image for that. But I still want to start out with a secure platform so that I know that I'm not introducing any vulnerabilities to my network. So this happens to be CentOS 7.2. I selected it out of the marketplace or whatever their fancy name is. And what I've installed so far is Git and the Chef workstation that actually owns the InSpec module. So I'm going to CD into my demos here just to keep everything together. And then I'm going to just download this thing with git clone. And then I'm going to run it right from the command line. InSpec, exec, Linux baseline. We'll accept this there because it's the commercial one and not the open source version. We'll ignore all the deprecations because open source has a life. All right, so like I said, this is just a basic machine that I have just instantiated. I don't know anything about it necessarily other than it meets my requirements for this new application that I want to be able to run. So I have this baseline that my security team has nicely provided for me, and the first thing I do is run this to see how out of whack all of this stuff is. So this particular baseline has, how many total down here? 26 successful controls, 27 failures, one that skipped maybe because of platform mismatch or whatever. So I end up with 80 tests. I have 80 successful tests and 45 failures. That's just a baseline, right? This is a random host that I just booted. And I know now that I'm starting with an insecure platform. I'm trying to build my application on sand. So this is automatically not going to meet my requirements. So the thing I can do now is, thanks to the InSpec open source community, is they have then components that work with these profiles to harden all these things up. So one of them where I'm going to happen to use Chef, but if you use another tool, they're also provided. And it sort of matches up with the things that are mentioned in the profile. So if you're familiar with Chef, we use recipes. If you use Puppet, they're modules. If you use Ansible, they're playbooks. But we then have all of these sort of fixes that can run around on the system and clean things up, right? They're scrub and bubbles. They're going to keep all this stuff cleaned up so that my baseline requirements will be met. And if you have your own profiles, you can also create your own scripts or modules or whatever to make sure everyone has a strong, hard place to run all their applications. So I have this stuff in a little demo here. I've already downloaded it. This will all be posted if you're interested. I'm happy to answer questions later as well. So I have a little Chef component that I'm going to use to fix this thing, right? So we'll see how it goes, right? It's open source. They could have released something this morning because they're all 10 hours ahead of us or whatever, so who knows? So we'll see how it goes. So at this point, I have a little piece of Chef that I'm going to let it create some cookbooks for me. And then I'm going to actually run it. Okay. Licenses, hello, thank you. Okay, so while that's running, this is going to go through and match up with all the tests that were run, so 125 or whatever they are, and make sure all the things that my security team are asking me to fix have been fixed in an applicable way, right? So after this is done, hopefully, everything's good, right? All I rerun my baseline, right? So I'm doing my test-driven development, right? I did my test first, it failed, and I'm gonna fix it and run it again. And I'm close, much closer. So if you can't quite see the bottom, it's 52 successful controls, 1 control failure. I've got 124 successful tests and 1 failure, right? So I can scroll through here and see, okay, what failed this time, right? In this particular case, I've got an audit D requirement that doesn't pass on this particular platform. I have a couple of options, right? I can go to my security folks and say, hey, I have this thing. What do you want me to do with it? Do I need an extra piece to fix it? Is it okay if I skip it for this particular example right now while I'm testing this? What would you like me to do? And you can actually have a conversation around the requirements, how applicable they are, do that communication and culture part of the DevOps wonder that you need to do. And then if my security folks said, you know what's okay, let's ignore that right now, go ahead and skip it on this profile, and we'll work on it for the next time. So I have the ability to actually skip stuff, which is super helpful. So my pipeline isn't necessarily held up completely right now. I can sort of ignore this for right now and come back to it. So with that, I have the ability to create new profiles that sort of wrap around existing profiles. And I have one here that I've already created to sort of serve as an example for this. So I've got one down here called My Hardening, right? And this is just basically based off of the Linux, the Chef cookbook being called OS Hardening. Similar name. So My Hardening has a couple of components. There's an inspec.yaml file, because we're all YAML engineers now, right? And I can tell it to say, all right, what you're going to do requires this Linux baseline. That's the thing that I'm required to be using right now that we're going to run first. And all I have to do is say, hey, go find this. I can give it a number of different places to go find the thing. If I have my artifact on a mounted drive, I can look for it there. This one happens to be in Git, or it might be some other URL, and it will download these things for me, which is pretty awesome, because then my security team can be in the background sort of updating this thing, and I can just pull down the latest whenever I need it. So I don't necessarily have to know exactly what version. I can just say, hey, go fetch that thing, right? So I'm depending on that. I'm going to pull it out of GitHub. But then I want to be able to skip this naughty thing right now that's giving me trouble. So I look in my controls directory, which is where all the code happens. And I've called one skipauditd.rb. And this, make it a little bigger. I'm basically going to tell the next time I run InSpec, I'm going to say, hey, you know what? In this profile, run everything from Linux baseline, but when you get to this naughty package 08, just skip it for now, right? It's still going to report on it for me. It's going to let me know how my things are doing, but I know I have this documentation here that I can skip this, and I can add comments here if I need to. I can publish this back to GitHub, whatever I need to do, so that everybody on my team knows what's going on with this. Right? So now I just have to run this particular version of this profile. And we'll see how it goes. Sometimes this works. Sometimes there's like some other thing that pops up. Last night I got an entropy error, because why not, right? So here we go. Now I can actually work with this thing. I've got it through my requirements. It says, all right, I've got all my successful controls. I've skipped some stuff that I know about that I can record for later. So now I have this platform that I basically just pulled from anywhere. Could be anything. I have secured it based on my requirements, and it took a couple of minutes, right? It's not a long process. Fortunately, I'm at the point where I don't have to change all of these things by hand. I don't have to download a PDF file and go through it line by line by line, right? Because it's not 1995 anymore. And now I have a secure platform to do whatever else I need to do on it for the next steps. So I'm installing my stuff and working with whatever application I'm working on. I can continue to run this later, right? Making sure that it hasn't made any changes to sysctl, that it hasn't made any changes to any of my other device settings, anything else that it might be sort of poking around with. So it's not in a place where we're looking at sort of a IDS, it's not a tripwire. This is very much proactive. looking at the system and my active requirements, things that I know about in advance that I want to make controls for, I want to be responsible for, I want to add in at the beginning. All right? So since I didn't have an additional step of things that failed, that's super awesome. You just never know. All right, some resources for you. So things to know about InSpec. InSpec lives at inspec.io. It also lives at dev-sec.io. There's additional community information there. There is a discourse rather than a Slack channel for this, but you can also join Chef's community Slack if you'd like to, and I'll post all this stuff and tweet about it. If you'd like to get additional information off our blog, we try to keep things updated there. And we have a bunch of modules that are all free on our learning site. One interesting blog post from a community about InSpec is a woman named Annie Hedgepeth. She went through InSpec a couple of years ago as a way to get into tech after being sort of out of the workforce with her kids for a while. So super interesting look. If you're not super familiar with infrastructure level hacking Linux sort of things, she takes a sort of journey through what she did to sort of get acclimated to the environment and the things that InSpec were giving to her. And it's super approachable. So just a really nice set of blog posts that she did. Danske Bank is one of our newer white papers on the commercial InSpec side that they have been using this, and a number of our financial institution customers have done that as well. If you're familiar with Barclays, they have a couple of things on YouTube about what they've been using InSpec for over the years. The demo is up on my GitHub as well. So, thank you very much for your kind attention. So we have a few minutes maybe for questions. Just go right here in the front. In this case, it is actually skipping the test in case it is something that would be damaging or potentially wrong for the actual platform. So it is actually not going to investigate that component this time around. So it just ignores it completely. There's one over here.
So I like these tools, but one of the things that always comes to my mind is my adding yet another privileged tool in my system that allows, if there's a problem with this system, that I'll end up being, I can mask my whole network. Does the language for InSpec, does it kind of provide a barrier where, hey, it only will let you do, say, read-only operations of data, and only they do things like they run arbitrary code on my system?
Yes and no. So he's asking about privileges of the actual runtime and not escalating through the actual tool, right, if there would be a problem. And the unfortunate sort of issue with that is because so much, especially on Linux, is actually privileged at read, like to actually test most of the common things, you need to actually have privileged access. So, you saw I was running into sudo and that sort of thing. There isn't I haven't seen them talk about actually like locking things down to say you're only allowed to do that. It would be an interesting feature, and maybe something if folks are into contributing, like that would be something awesome to look at, absolutely. One more?
Yeah. Oh. So if you can have a desired state of the machine with Chef, Ansible, Puppet, what's the point of running InSpec at all if I can run that daily and have that desired state?
Yeah, so part of it comes down to like whose responsibility all this stuff is, right? So, you figure out whoever's owning sort of the infrastructure code, like that's usually a team, and we've found this with our customers, that's a team that sort of works in one area of their influence, right? So they're working on the infrastructure code, they're running the applications, those sorts of things. And like the previous speaker mentioned, like there's not always enough security folks, or they're certainly not embedded with those teams. So if you have a place where you have a lot of security folks in other places that have a lot of other requirements, or you want to make sure that globally across all of your applications, regardless of whether you've got a brand new fancy DevOps team on here or these sort of legacy infrastructure engineers over here, that you have a place where all this stuff sort of combines and everybody can share it. So that's sort of one of the places where InSpec really does the big job, is where it's a place where everybody's combining all their knowledge into one place. So, anything else? Is that good? Thank you, Francois.